So today we're going to be doing the types of reactions lab. So I've gathered a test tube rack, and these numbers here are going to correspond to which station number we're on. So the number 1 test tube is in the station, is going to be used for station 1. 10 stations, 10 test tubes. I'm going to be careful not to drop them on the floor, or at least try not to. Okay, so here we are at station 1, and it says transfer approximately 3 milliliters of 6 molar hydrochloric acid to a test tube. Then we will add a few zinc pellets to the tube and record our observations. That gas involves CO2 or other non-flammable gas, or is it hydrogen gas, which is very flammable when it combusts? We are going to be inverting a test tube over the test tube to collect any gas that forms, and then light a match to test its flammability. So, get started. These volumes don't have to be precise, so I'm just going to hold up 3 fingers next to there to get my 3 milliliters. So that's approximately 3 milliliters. And now I'm going to grab a piece of zinc. See, there's all sorts of shapes and sizes in here. I'm just going to put that in there. Whoa, look at that. That's a lot of bubbles forming. So, the test tube is also getting hot. So I'm going to go put it down here and hold that over there to collect some gas. Hold it right over, right on top. Nice seal. And give that a few seconds to collect the gas inside before we try to light it. All right, should be making lots of gas inside that tube. All right, when I get the match close, just lift up a little bit for me to slip the match in. Come on.
No,
Both of these are, oh gosh, those were loose. So, there we go. Open, lift it. Whoa! I hope you heard that. I heard that. Okay, I'm just going to pick up these matches that fell on the floor. So we heard a very loud sound. So that must mean that the gas inside there was flammable. Okay, so let's move on to station 2. Station 2 says, in a test tube mix 1 milliliter of barium chloride with 1 milliliter of sodium sulfate. So it's a good test of your nomenclature. And so it says, what happens when you mix the 2 reactants? What does the test tube look like after 3 to 5 minutes? So we don't have to stand here for 3 to 5 minutes. We can always let it sit in our test tube rack and keep working. But I got to add 1 milliliter of each of these. So I'll hold my finger up there. That's an approximate measure of 1 milliliter. Okay. And now I'll add 1 milliliter of this one. Whoa. Turned white. Cloudy, kind of like milk. No temperature change, but there is definitely some kind of white, cloudy substance in there. Most likely some sort of solid. Okay, we'll see what that looks like in another 3 to 5 minutes. something definitely happened there. All right, moving on to station 3. Station 3 says in a test tube mix 1 milliliter of barium chloride with 1 milliliter of sodium phosphate. So I'm going to take 1 milliliter of each of these and mix them together. So there's 1 milliliter of that. And 1 milliliter of this. Whoa. That looks awesome. You can see definitely white and cloudy. I can give it a little shake. It's good to cover the top of it though if you're going to shake it. Mix it all together. Chemical reactions, you need stuff to actually mix together. But as that's reacting, you can see that there's definitely some kind of white, cloudy solid of some kind in there. All those white, cloudy things are some kind of solid. That's all we know right now. Oh, I didn't grab my lab manual. Okay. So next up, again, there was no temperature change for that last one. So here we are on station 4. Station 4 says in a test tube mix 2 milliliters of sodium carbonate with 1 milliliter of hydrochloric acid. And then it says, is a gas evolved? What compound is responsible for it? What happens to the solution over time? But anyway, let's get started. I'm going to add approximately 2 milliliters of the sodium carbonate solution. So I added about 2 milliliters of this. Now I'm going to add another milliliter of this hydrochloric acid. I'm going to add this one slowly because it's sometimes can be a little bit violent. Oh. So there's definitely a gas being evolved. What's cool about this reaction is that the hydrochloric acid is more dense, and so it sinks, and you can actually see a seam where the two liquids meet. And the gases are coming right out of that seam where the two liquids are meeting. And so that's pretty cool. And so you can shake it, and the bubbles are all coming from where the two liquids meet. They don't start from the bottom. So as we get those two to mix, the reaction will keep going until all of them are fully mixed and fully reacted. But pretty cool. Definitely some kind of gas coming out of that one. Is there heat? I don't really feel that much heat, maybe a little bit, but nothing substantial. Oh yeah, station 5 is behind us. So I gotta come back here for station 5. Good call for my lab partner. Okay. So on station 5, it says transfer approximately 1 gram of copper sulfate into a dry test tube. This compound is a hydrate salt that has 5 water molecules associated with each formula unit. While holding the test tube with a test tube clamp, gently warm it using a Bunsen burner. Record your observations. And then we have to look at the neck of the tube and the bottom of the tube. So I'll go ahead and get this in here, and then I'll light my Bunsen burner. That's good enough. I don't need a whole lot. Okay. Turn that on. It's definitely open. Oh, there we go. I don't need it super ridiculously hot, but I do want to get rid of the yellow flame. Okay, so I'm going to put the test tube clamp from the top of this and make sure I don't put the wood inside the fire, because wood burns, and that's not the chemical reaction I'm looking for. So I'm just going to hold this in here, and you can see in the neck of the test tube, it's starting to look a little foggy. And then the solid down at the bottom of the test tube is changing from a blue color to a white color. Oh, yep. The test tube definitely looks wet now, like droplets. And you can see the steam coming out of the neck of the test tube. Okay. Now if I kept this in here, I could get all of the blue solid to turn white. But I don't need to keep it in there for that long. So I'm going to shut off my Bunsen burner and give this a moment to cool. And I'm going to, well, we're still in here. Motion sensors.
Nope, that's a power outage.
Oh, that's a power outage. We have to add 20 drops of water to this, and I left my deionized water bottle over here. So well, after adding water, the solid down at the bottom turned back blue. So that gives us a clue about what happened in this process. This wasn't a chemical reaction, this was a physical change. So we're not going to be classifying this reaction because it wasn't really a reaction, it was a physical change. But still pretty cool to look at. Okay. Next up, we're going to Station 6. Station 6, turn my test tube rack around. Okay, so Station 6 says that we have in a 1 milliliter test, in a test tube, mix 1 milliliter of calcium chloride with 1 milliliter of sodium carbonate. So I need 1 milliliter of each of these. So here's my Station 6 test tube, and I'll quickly add 1 milliliter of both of these. Okay, and so it turned white and foggy. Kind of looks close to stations 2 and 3. It does not feel warm. Some kind of solid formed there. Now we're on to Station 7. Station 7 says in a test tube, mix 1 milliliter of hydrochloric acid with 2 milliliters of sodium hydroxide. So I need 1 milliliter of this and 2 milliliters of that. So start with adding the hydrochloric acid. That's a bit much. I'll add the sodium hydroxide slowly. Whoa, definitely getting hot. You might have seen a little bit of steam coming off there. Yeah, can feel the warmth. but it still looks clear on the inside. Can look, there's a seam there where the two liquids are meeting. That means they're not really mixing. So trying to shake it up a little bit. But overall, I can feel the heat, but it still feels clear, or it looks clear. All right. Station 8. Station 8 says I need 1 milliliter of each of these. We got potassium nitrate and barium chloride. So 1 milliliter of potassium nitrate and 1 milliliter of barium chloride. Okay, so I feel no heat at all. Test tube feels the same temperature. It still looks completely clear. No sign of bubbles or anything. So, doesn't really look like anything really happened there. All right. Now on to station 9. Station 9 says in a test tube, mix 1 milliliter of sodium chloride with 1 milliliter of silver nitrate. So 1 milliliter of that. And 1 milliliter of this. And that turned white and foggy. So some kind of solid forming. No heat coming off. No bubbles, but definitely some kind of white solid formed there. Okay, last station. Last station says in a test tube mix 1 milliliter of 5 molar ammonium chloride, but I'm given a solid, so I'm just going to use the solid, and 1 milliliter of 3 molar hydrochloric acid. So,
Sodium hydroxide.
oh, sodium hydroxide. So I need a scupula so I can get a small amount of that out. So I got a small amount of that out. And then in the instructions, it says that I'm supposed to hold a piece of moistened red litmus paper over the test tube. So before I get carried away, I'm going to go ahead and take out a piece of red litmus paper and moisten it. That's why the deionized water is over here, for me to moisten this red litmus paper. Okay, so that's moistened. I'm just going to set that here until I need it. Okay, so I'll take my sodium hydroxide and add some of that. The ammonium chloride floated. I'm going to go ahead and hold this over and see if there's something happening there. And if we look, the red litmus paper is turning blue. right over the mouth of the test tube. So that's an indication that some kind of gas is coming off that will turn our litmus paper colors. So it also says that I can smell this, so I can hold this and I can waft the vapors towards me. And yeah, it smells like ammonia. If you don't know what ammonia smells like, then you should go smell Windex, because that's what this smells like right now. So that was not a solid that formed, that was just ammonium chloride salt that wasn't fully dissolved yet. But if we keep shaking this, we can get all that ammonium chloride to dissolve. So now it's fully reacted. So the litmus paper definitely does change color there. Great. So you can go ahead and record all of your observations, and we can go back and look at the earlier test tube. So that's station 2, and some of the solid has sunk down to the bottom. And this is station 3, and more of it has sunk down to the bottom. And we have power again, thank goodness. So both of those, the solid sunk down to the bottom. That one looks totally clear now. That one's blue still. That one is still bubbling. Are you sure it's not the motion sensor?
That one might be.
Yeah, that's the motion sensor. Okay, so yeah, pretty cool. All of these different chemical reactions. All right. Make sure you write your balanced molecular equations and complete ionic equations and net ionic equations.